If you're going to do any night boating, you should really know how to navigate at night, and you should know how to read chart lights. If you don't know how to read night lights on a chart, then you're not really competent to be out at sea. Let's have a look at night lights on a chart and see how the lights are indicated, so that, as we've seen how to navigate during the daytime using the markers, there is a system of how to navigate at night. Let's have a look at it now. Now, you may have been wondering just what the bold print is beside the navigation markers we've been looking at during the daytime. Well, that bold print enables us to navigate at night. The port markers we're seeing here have a red teardrop, which indicates the colour of their light at night, and the bold print beside them indicates the flashing sequence. For example, this one here is flashing red every 2.5 seconds. So you'll find on a chart that all of the different light sequences in a group are unique, so that if you were completely lost at night, what you do is look around your 360 degrees, work out all the light sequences that you could see, write that down, and then go back to the chart and locate that spot. Here's an example of flashing red every 2.5 seconds. Here's another example. You can see this is a special mark. Special marks have a yellow light at night. The bold print here says flashing yellow every 4 seconds. So in every 4-second cycle, that light will flash once. Here's a starboard marker. You can see it's got a green teardrop, which indicates a green light. The bold print says QG. Q stands for quick, so it's saying quick green. And what does quick mean? Well, to work out what quick means, what you really need is a table which explains all the different light sequences. There's quite a number of them. We'll go through the most common ones now. The way this table works is that on the left column it shows us the definition of the light. The middle column tells us the abbreviation we'd see on the chart, and the right column shows an example of its flashing sequence. So if we go down to quick, you can see it there in the middle. Quick, 50 to 79, usually 50 or 60 flashes per minute. In other words, 1 a second. Let's have a look at some other lights as well. You can see down here, very quick. Its abbreviation is VQ. Usually either 100 to 120 flashes per minute. In other words, approximately 1 every half second. We saw some flashing earlier. Let's just have a look at flashing. The definition of flashing: total duration of light is less than dark. So for example, if it was flashing every 3 seconds, then at the 3-second mark it would go flash. 3 seconds later, flash. So 1 flash every 3 seconds. We're looking at a couple here. You can see the top one is fixed. Now you'd typically expect to find a fixed light, for example, on a bridge lead light. The example you're seeing here is a fixed blue. You can see the one below it says occulting. Occulting, total duration of light, is more than dark. And you can see the abbreviation there is OC. So if it was occulting every 5 seconds, it might be 4 seconds on, 1 second off. 4 seconds on, 1 second off. So 4 seconds of light followed by 1 second of darkness. Another example we have there is isophasing. Light and dark are equal. The abbreviation on the chart is ISO. So if it was isophasing every 2 seconds, it might be 1 second on, 1 second off. 1 second on, 1 second off. So an equal amount of light and dark. You can see here we're looking at a special mark. This one says flashing yellow every 4 seconds. The light itself is 5 metres above the high water mark, and you can see that light in good visibility for 8 nautical miles. Here there's another example of a special mark. This one says flashing yellow in groups of 5, and that's happening every 20 seconds. So in every 20-second cycle, that light will flash 5 times. Here's an example of a safe watermark. This one says ISO every 4 seconds. Well, that's isophasing every 4 seconds, which means 2 seconds on, 2 seconds off. Let's have a look at the night lights of the cardinal marks. They've all got a white light at night, but they have a different flashing sequence. If it's a north cardinal mark, it'll either be quick or very quick, and that'll be non-stop all night. Then it flows like the hands of a clock. If it's an east cardinal mark, it'll flash in groups of 3. South cardinal mark will flash in groups of 6. West cardinal mark, flash in groups of 9. So the north represents the 12 o'clock, then it goes east is in groups of 3, south is in groups of 6, and west is in groups of 9. Now if there's a group of cardinals in close proximity, it can be difficult to work out the west cardinal mark from the south cardinal mark. So to make it easier, what they do is they'll follow the 6 quick flashes of the south cardinal mark with 1 long flash. So to be quick or very quick in groups of 6, followed by 1 long flash, and that'll denote the south cardinal mark. Here's an example of a west cardinal mark, quick in groups of 9 every 15 seconds. Quick just by itself, with no flashing sequence, indicated would mean a north cardinal mark. Quick in groups of 6 plus a long flash every 15 seconds means that it's a south cardinal mark. Just for your interest, let's have a look at a chart and see how the lighthouse lights work. We're looking up here at Cape Morton. There's 2 lighthouses up here. The one on the left, 2 lights, it's got a white and a red. The bold print says quick white red. The light's 25 metres above the high water mark, and you can see that light for 9.8 nautical miles. This bottom one here, it's got a white teardrop, so it would have a white light at night. It's flashing in groups of 4, and that's happening every 20 seconds. It's 122 metres above the high water mark, and you can see that light for 27 nautical miles. Now, if you're coming in on a white sector, you'll be safe. If you're coming in on a red sector, then you're in danger of running aground. You can see the reefs and shoals that are just out here in this red sector. The way your lead lights work on a chart, there's the white triangles which would indicate the lead during the daytime. The way the night lights work, the front lead is a quick yellow, so once every second, that'll give a yellow flash. The back lead is isophasing yellow every 2 seconds, which means 1 second on, 1 second off. So you line up the front quick yellow light with the back light coming on every 2 seconds, and that's how you'd guide you in through the channel. Let's have a look at one last lighthouse. There's a lighthouse here at Cowan Point. You can see it's got a combination of lights. It's got a white, a red and a green. Now the bold print says flashing white, red, green every 2 seconds. The light's 9 metres above the high water mark, and you can see that for 10 nautical miles. And the lights are sectored, so there's your white sector, meaning it's safe. And what does it mean when on a chart you can see markers which don't have a teardrop or any bold print describing night lights? You guessed it, means they're not lit at night. On an Admiralty chart, there's no colour differentiation for the night lights, so you've got to use the flashing sequences to work out what type of night light it is. The example you're seeing at the moment is flashing in groups of 2, and that's happening every 10 seconds. Isolated danger marks always flash in groups of 2. That's one of the rules, so the one you're seeing there now is a danger mark. If no colour is indicated in the description of the light, the default colour will be a white light. This example on the Admiralty chart is a simple one, flashing yellow every 4 seconds. Yellow light at night would indicate a special mark. So that's night navigation. What I suggest you do before you wander out there at night is obtain a chart of your local area and go through the night lights that you'll be encountering before you get out there. Much easier to work these things out in the comfort of your own lounge room rather than in a bobbing boat out in the middle of the ocean. Let's have a closer look at charts and see some of the other information which can be found on a chart. One of the things you first notice when you look at a chart is the numbers that are all over it. These numbers are the depths. On a metric chart, depths are in metres and tenths of metres, and on an Admiralty chart, the depths are in fathoms or metres. Now these depths indicate the lowest astrological tide, which is the water level at the lowest tide ever recorded at that place. As an example, you can see some of the depths indicated around Gilligan's Island here. This is a metric chart, so the depths here are saying just above Gilligan's Island 0.6 metres, just below Gilligan's Island 16.4 metres. Both types of charts are colour-coded. The example you're seeing here is a metric chart. On a metric chart, the deeper the water, the darker the blue, and as the water gets shallower, then it goes to a whiter colour, and then when it becomes unnavigable at low tide, it's coloured in a motley grey. And you can see the depths here reducing as the numbers get closer to land. Depths that you see on a metric chart, which have an underline underneath them, indicate that at low tide, that is a drying height. So for example here we might have a 0.5 with an underline underneath it, then that's half a metre out of water at the lowest tide. Another thing you'll notice on metric charts is the black squares which form a grid across the chart. Those squares are related to your scale. On the chart we're looking at here, each black square equals 2 kilometres. So it's a quick and easy way of working out distance. You just add up the number of squares. These blue arrows you can see indicate the direction and the speed of the tidal flow. Arrows with a feather on their tail show you the way the tide flows in. Arrows without the feather show you the way the tide flows out. And the speed of the tidal flow here is 3 knots. On some metric charts you might also see blue lines which have been drawn in. These blue lines have compass bearings associated with them, and they mark popular trips which people do from point A to point B. To save boaties having to work out any of their own compass bearings, the authorities in this chart have drawn in the blue lines, and they've also included the compass bearing. These blue lines have the magnetic compass bearing showing you the bearing to get from point A to B, which makes it easy for you. You just follow that magnetic bearing, saves you having to work it out yourself. Most other information which you'll see on a chart is given to you in the legend. There is a book of chart symbols which is about 1 inch thick, and that book can be obtained through good marine bookstores.